Good morning everyone. My name is Padmashree Mehta and I am here to present my IoT internship project titled IoT based home automation system. This project was developed as part of my internship at Emertxe Technologies and focused on implementing a smart home automation system using Arduino, Picsimlab and BlynkIoT app. And during this internship, my domain was the IoT, which is Internet of Things. This internship was a 4-week program combining theory sessions and practical project development. I worked with tools such as Arduino IDE, Picsimlab Simulator, and BlynkIoT app and Virtual Serial Port Emulator. This program helped me to understand how IoT connects embedded systems to the real-world application. And throughout this internship, I learned key concepts in embedded C programming such as data types, control structures, functions, pointers, and memory management. I also explored C++ and OOPS concepts, understanding features like inheritance, polymorphism, and abstraction. On the IoT side, I learned how to set up Arduino interface sensors and connect devices to the BlynkIoT app for remote monitoring and control. Overall, you know, Overall, I developed a strong understanding of how embedded systems and IoT combines to create smart solutions. Um, Coming to project requirements, the main objective of my project is to simulate a home automation system. It was implemented using both hardware and software components. As hardware includes Arduino Uno, LDR sensor of light controlling, and LM35 sensor for temperature, and CLC display, relay module for heater, cooler, and inlet and outlet valves, and simulated serial time. And the software tools including Arduino IDE, Picsimlab and BlynkIoT app, and virtual serial port emulator. And functional modules such as garden light control. It uses an LDR sensor to adjust LED brightness automatically based on the light intensity. And its temperature control system. It reads temperature using LM35 sensor and control the heater or a cooler, etc. And water tank management. It measures tank level using serial data and control inlet and outlet valves. These modules together form a complete smart home automation system. And coming to block diagram for temperature controller, and this block diagram represents the temperature control module, and the LM35 sensor senses the temperature and sends the data to the Arduino. Based on the temperature value, the Arduino operates the heater or a cooler through the relays, and the status is displayed on the CLCD and the Blink app, allowing real-time monitoring and control. If the temperature exceeds a set limit, and heater automatically turns off to ensure safety. And next block diagram for water tank. And here we can see the water tank level control system. The simulated serial tank sends water level readings to the Arduino through serial communication. And the Arduino control the inlet and outlet valves using relay based on the tank level. And the status and level are displayed on the CLCD and also on the Blink app, making it easy to monitor and control remotely. Coming to simulation part, here temperature display on CLCD, and the slide shows the CLCD output for temperature display. The LM35 sensor continuously reads the temperature and the Arduino displays it on the CLCD, and the Blink gauge widget. Here the heater and cooler are both in off condition since the temperature is within normal range. And next, garden light control using LDR sensor. Here the image shows LDR based garden light control. When the light intensity decreases, the LED automatically turns on. and the CLCD displays both the LDR value and light status in real time. Next, water tank level monitoring. This slide shows displays how Arduino reads tank levels using serial communication. Both the CLCD and Blink app shows the current water level volume. And based on the water level, the inlet and outlet valves are automatically turned on or off. Next, heater activated via Blink app. In this, the heater is switched on using the Blink app, and the relay activates the heater and the CLCD updates the system status to the show heater on. This shows the IoT control capability of the project. And next, heater auto cutoff. And this shows the auto cutoff function of the heater. When the temperature crosses the threshold, the heater turns off automatically. Yeah. And next, cooler activated. Cooler activated through the Blink app. It relay turns on the cooling fan and the status is updated on CLCD. And the next, cooler off. Cooler off condition. The temperature remains in normal range, the cooler stays off, and the CLCD clearly shows the both heater and cooler are off, indicating the stable temperature condition. And coming to complete demo using BlynkIoT app, and here I will show a video and how it completely works and show what um, is home automation. Yeah, here it shows a volume, present volume shows in LCD, and here we also see the outlet wall is in off mode. Using BlynkIoT app, here you can see inlet wall and outlet wall and the volume. If inlet wall is on mode, the cereal tank and the water can fill. Outlet wall and water can be drawn. And also here we can see a volume and water condition will be displayed. If inlet wall on, the water gets filled into the tank. Off condition, it will off. Outlet wall, the water will be drawn outside. And also we can see here heater on and heater off displayed in CLCD, and cooler off displayed in the CLCD. And above is the BlynkIoT app. We can use it to shows heater on, cooler off. And coming to LED, light intensity is decreases, then LED glows. Yeah, it shows the condition of garden lights based on the temperature. Yeah, this is complete project of the demo. And finally, the system successfully automates and monitor lighting temperature and water levels using sensor feedback and IoT control. So the Blink app, we can control all modules remotely and view real-time updates, making the system efficient, interactive, and user-friendly. This project truly reflects the practical use of Emertxe and IoT integration. And to conclude this, internship helped me to gain valuable hands-on experience in IoT and embedded systems. And I learned to integrate coding, simulation, and cloud connectivity into one functional project. And I sincerely thank my mentors at Emertxe Technologies for their constant guidance and support. Thank you.